Good morning, my dear students. Welcome to my physics class. Look at the pictures below. What are you observing? In the first picture, the car is not running, but in the second picture, the car is running. Here, this car is not moving, but here the car is running on the road. So, the car 1 is at rest and the car 2 is in motion. This car is at rest and this car is in motion with respect to their surrounding. So its state is rest and its state is motion. So our today's topic is rest and motion. Let's start now. If I ask you what is the position of your school, then probable results may be, you can say at Pabna. If you say at Pabna, then the position of your school may be at this position, this, 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 this. That at any position among them. That is, if your answer is at Pabna, then position may be any place inside this Pabna. So if the answer is at a distance 1.5 kilometer from bus terminal, then it may be here 1.5 kilometer from bus terminal, and here also 1.5 kilometer from bus terminal, here 1.5 kilometer, here 1.5 kilometer. That is, the position may be at any place from bus terminal, that is 1.5 kilometer from this bus terminal. So here 1.5 kilometer distance, here 1.5 kilometer distance, and here 1.5 kilometer distance, and in any direction 1.5 kilometer distance can be obtained, and exact location of the school is not obtained by this answer. Here also we cannot find the exact location of the school by this answer. If the answer is at Pabna, the probable location may be this, and if the answer is at a distance 1.5 kilometer from bus terminal, then the location of the school may be any location. And if the answer is at a distance 1.5 kilometer west from Pabna bus terminal, then it will be here bus terminal, and 1.5 kilometer west from Pabna bus terminal, that is here 1.5 kilometer, and obviously we will get the exact location of the school. So now the proper answer is got. Now the position of the school is specified properly. That is, by this answer we can find the exact location of our school from bus terminal. Here in this case bus terminal is reference frame. That is, we have measured the distance of our school from bus terminal. So bus terminal is the reference frame or origin. So you can say reference frame, the observer with respect to whom position, rest and motion are determined is called reference frame. Here we have measured the distance of our school from bus terminal, and it is 1.5 kilometer west from the bus terminal. So bus terminal is the reference frame, and reference frame may be a point, place, person, building or object, etc. So reference frame means the observer with respect to whom position, rest and motion are determined is called reference frame. If you want to measure the exact location or position, if you want to measure the rest and motion, so we need a reference frame. Without reference frame we cannot measure or determine the position, rest and motion. So it is very essential. Now rest. If an object does not change its position with respect to a reference frame, then the object is said to be at rest and the state of the object is called rest. That is, with respect to a reference frame, if the object does not change its position, that is, position of the object will remain same with respect to a reference frame, then the object is said to be at rest and the state of the object is called rest. That is, this state of the object is rest. Example, a tree is at rest with respect to a building. If you consider a tree beside a building, then the position of the tree will not be changed with time. That is, from the building, position of the tree will not be changed. So tree is at rest with respect to a building. Also, the tree is at rest with respect to a lamp post. A tree is at rest with respect to another tree, etc. Motion. If an object changes its position with respect to a reference frame, then the object is said to be in motion and the state of the object is called motion. So in this case, the position of the object will be changed with respect to a reference frame, and then the object is said to be in motion and the state of the object is called motion. Example, a running car is in motion with respect to a lamp post. The distance or position of the car will be changed with respect to a lamp post if the car is running, that is, if the car is in motion, then the position of the car will be changed with respect to lamp post. So the car is in motion. Here look at the pictures. Here, with respect to the surrounding or any building, this position of this car are changing. So this car, that is the state of the cars are motion, that is this car are in motion, and this bus, the position or distance of this bus is not changed with respect to surrounding or this building, so its state is rest. So we can say this car are in motion with respect to this building and this bus is at rest with respect to this building. So here this bus is at rest position and all the cars are in motion. And if we consider this bus as a reference frame, with respect to this bus, these cars, buses are in motion. That is, these moving cars and buses are in motion with respect to this bus at rest. And if we consider any running car as a reference frame, then this bus is also in motion with respect to the reference frame which is in motion. That is, reference frame may be this bus or any car, that is, which are in motion. That is, reference frame may be at rest or in motion. If we consider this building as a reference frame, then the state of the bus is at rest. But if we consider this moving car as a reference frame, then with respect to this car, the position of the bus will be changed. So the bus is in motion with respect to this car. Here also, this is a running train. This train is in motion with respect to the person standing on the platform. That is, now the train is in motion, and here passengers inside the train. These passengers are also in motion with respect to this person. That is, position of the passengers are changing with time with respect to this person standing on the platform. So all the passengers and this train are in motion with respect to this person. But here, if we consider this passenger as a reference frame, then with respect to this passenger, the position of this passenger is not changed. So she is at rest with respect to this passenger, but she is in motion with respect to this person. So same object, same person, same thing can be at rest with respect to a reference frame and can be in motion with respect to another reference frame. That is, this passenger is in motion with respect to this reference frame, but this passenger is at rest with respect to another passenger of the train. And also this train is at rest with respect to the passenger, but this train is in motion with respect to the person standing on the platform or respect to its surrounding, that is tree or any lamppost. The train is in motion, but inside the train one passenger is at rest with respect to another passenger because the position is not changed with another passenger. So they will seems to be at rest with respect to each other, but they are in motion with respect to the person standing on the platform. The passenger of train is in motion with respect to a person standing on the platform, but at rest with respect to another passenger. That is, same passenger is in motion with respect to this person, and same passenger is at rest with respect to this passenger. Here, the observer or reference frame is in motion, and here parachute is also in motion. That is, both of them are in motion with same velocity. Therefore, the distance between them, that is position, is not changed with respect to one another. So they are at rest with respect to one another. That is, the parachute is at rest position with respect to this observer or reference frame, and this parachute is also at rest with respect to this parachuter because the position is not changed with respect to the parachuter. So parachute is at rest with respect to the parachuter, and it is also at rest with this reference frame which is in motion. Here reference frame may be at rest or in motion. So here the observer or reference frame and parachute are in motion with same velocity. Though they are both in motion, but with respect to one another, their state is at rest. Now, absolute rest. If an object does not change its position with respect to a reference frame which is absolutely at rest, then the state of the object is called absolute rest. That is, here with respect to a reference frame which is absolutely at rest, that is, reference frame must be at rest position absolutely, that is, really the reference frame is at rest position. If we get this type of reference frame, then with respect to this reference frame, if the object does not change its position, then the state of the object is called absolute rest. So to get absolute rest, we need a reference frame which is absolutely at rest position. And absolute motion. If an object changes its position with respect to a reference frame which is absolutely at rest, then the state of the object is called absolute motion. That is, if we get a reference frame which is absolutely at rest position, that is really at rest position, then with respect to this reference frame, if an object changes its position, if an object changes its position with respect to a reference frame which is absolutely at rest, then the state of the object is called absolute motion. So if we want to get absolute rest and absolute motion, we need a reference frame which is absolutely at rest position. The reference frame must be at rest position. It is not possible to get a reference frame which is absolutely at rest position. So it is not possible to get absolute rest and absolute motion, because our earth is rotating about its axis and also it is rotating around the sun, and the sun is also rotating, and everything in our universe is rotating, that is, all the object in this universe is in motion. So it is not possible to get any reference frame which is absolutely at rest position. All things in this universe are in motion. It is not possible to get a reference frame which is absolutely at rest position. Everything in this universe is in motion, so there is no absolute rest and absolute motion. All rest and motion are relative. Because to get absolute rest and absolute motion, we need a reference frame which is absolutely at rest position, as there is no object which is at rest, absolutely at rest, so it is not possible to get this type of reference frame. And an object may be at rest position with respect to a reference frame, and it may be in motion with respect to another reference frame. So the state rest and motion depends on observer or reference frame. That is, with respect to a reference frame, the object may be at rest position, or with respect to another reference frame, the object may be in motion. So the rest position or motion are relative. No rest or no motion is absolute. So all rest and motion are relative. Now evaluation. If you measure the distance of your school from your home, which one is the reference frame? Your home, your school, you, and bus stand. Which one is correct? If you measure the distance of your school from your home, which one is the reference frame? Your home, your school, you, bus stand. And the correct answer is your home. If you measure the distance of your school from your home, then your home will be reference frame. To specify the exact position of an object, we need a reference frame. All rest and motion are relative. Now your homework. Why are all rest and motion relative? Explain it. Thank you very much.